Have you ever wondered what's really going on inside a volcano? These massive mountains aren't just sitting there. They're gateways to a world of molten rock deep beneath our feet. Today, we're going to dive into the fiery heart of our planet and uncover the explosive secrets of how volcanoes erupt. So let's start from the bottom up. Literally, deep within the Earth's mantle, the rock isn't solid. It's under immense pressure and is incredibly hot enough to melt. This molten rock is called magma. Because magma is less dense than the solid rock surrounding it, it begins to rise, much like a hot air balloon floating up through cooler air. This rising magma collects in large underground pools known as magma chambers. Think of these chambers as giant holding tanks, sometimes just a few kilometers beneath the surface. As more and more magma flows into the chamber, the pressure builds. It's like shaking a can of soda. The pressure inside gets higher and higher, just waiting for a weak spot to burst through. What happens next depends heavily on the magma's recipe, specifically its viscosity and its gas content. Viscosity is just a fancy word for how thick or runny a liquid is. Honey has high viscosity, it's thick, and flows slowly. Water has low viscosity. It's thin and flows easily. This brings us to our first type of eruption, the effusive eruption. This happens when the magma is low in viscosity, meaning it's runny and also low in dissolved gases. Because it's so fluid, gases can escape easily, like bubbles rising gently from a pot of simmering water. The pressure doesn't build up to extreme levels. When this type of magma reaches the surface, it doesn't explode. Instead, it flows out, creating rivers of lava that can travel for many kilometers. These are the kinds of eruptions you often see in places like Hawaii, with spectacular, glowing lava flows that build up broad, gently sloping volcanoes called shield volcanoes. While they might look calm from a distance, these lava flows are incredibly destructive, burning and burying everything in their path. But what happens when the magma is different? This is where things get truly explosive. The second type of eruption is, you guessed it, the explosive eruption. This occurs when the magma has high viscosity, it's thick and sticky, and is packed with dissolved gases like water vapor and carbon dioxide. Because the magma is so thick, the gases can't escape. They remain trapped, and as the magma rises and the surrounding pressure decreases, these gases expand dramatically. It's the ultimate shaken soda can. The pressure builds to catastrophic levels until the rock above can no longer contain it. The result is a violent, explosive blast. The magma is shattered into tiny fragments of rock, ash, and glass that are blasted high into the atmosphere. This mixture of hot gas and volcanic debris is called a pyroclastic flow, and it's one of the most dangerous volcanic hazards. It's a superheated, fast-moving avalanche of destruction that can travel at hundreds of kilometers per hour, incinerating everything it touches. These explosive eruptions are responsible for creating the classic cone-shaped volcanoes we often picture, known as stratovolcanoes, like Mount Fuji in Japan or Mount St. Helens in the United States. The 1980 eruption of Mount St. Helens is a perfect example of this power. The blast was so immense that it blew the entire top and side of the mountain clean off. Let's talk more about the hazards, because it's not just about the lava. The ash from an explosive eruption can be a major problem. It's not soft like ash from a fire. It's made of tiny, sharp particles of rock and glass. This ash can travel thousands of kilometers on the wind, blanketing entire regions. It can collapse roofs, contaminate water supplies, ruin crops, and disrupt air travel by clogging jet engines. Inhaling it can cause serious respiratory problems for people and animals. Then there are volcanic gases. Volcanoes release a cocktail of gases, including sulfur dioxide, carbon dioxide, and hydrogen fluoride. Sulfur dioxide can lead to acid rain and respiratory issues, while large, concentrated releases of carbon dioxide can be deadly. As the gas is heavier than air and can collect in low-lying areas, suffocating anyone there. Another significant hazard is lahars. Lahars is essentially a volcanic mudflow. When hot volcanic material melts snow and ice on a volcano's summit, or when heavy rain follows an eruption and mixes with loose ash and rock, it creates a fast-moving slurry that looks and behaves like wet concrete. Lahars can rush down river valleys at incredible speeds, burying entire towns and changing landscapes in an instant. The 1985 eruption of Nevado del Ruiz in Colombia tragically demonstrated this. The lahar buried the town of Armero and claimed over 23,000 lives. Even the very structure of the volcano can be a hazard. A flank collapse, where a side of the volcano gives way, can trigger massive landslides and even tsunamis if the debris falls into the ocean. The explosive eruption of Krakatoa in 1883 caused the volcano to collapse into the sea, generating a tsunami that was one of the deadliest in recorded history. So how do we protect ourselves from such powerful forces of nature? This is where volcanologists come in. Scientists monitor volcanoes around the clock, using a variety of tools. They use seismometers to detect the small earthquakes that often precede an eruption, as magma moving underground makes the ground tremble. They use GPS and tilt meters to measure ground deformations, subtle swelling or tilting of the volcano surface as the magma chamber fills. They also analyze the gases being released from volcanic vents, as changes in gas composition can signal that magma is rising. By combining all this data, scientists can make forecasts about when and how a volcano might erupt. These warnings give authorities crucial time to evacuate people from hazardous areas, saving countless lives. We can't stop a volcano from erupting. Understanding the science behind them allows us to coexist more safely with these magnificent and powerful giants. From the slow creep of magma deep within the earth to the thunderous explosions that reshape our world. The story of a volcano is a dramatic tale of pressure, chemistry, and immense power. It's a constant reminder that our planet is alive, dynamic, and always changing. Thank you so much for joining me on this journey into the world of volcanoes. If you found this fascinating, don't forget to hit that like button, subscribe to the channel, and ring the notification bell so you won't miss our next adventure. Let me know in the comments which natural phenomenon you'd like us to explore next. See you in the next video.